welcome back to AGT STEM. Today we're going to be watching a video about thallium. It's a pretty long video, so hopefully you stay in there. Let's get to it.
We're going to talk about thallium. Lots of exciting things, murders, a fantastic flame colour, nice precipitates, and it's very poisonous. I wasn't in the lab when the experiments were done, and I was quite pleased because thallium poisoning makes your hair fall out. Doesn't worry Neil, but makes me feel very nervous.
You look like you've had some hair fall out anyway.
Well, it's been cut a bit, but even Mendeleev had his hair cut once a year. Neil got a nice sample of nearly 50 grams of thallium, and if you heat it up, it does melt at quite a low temperature.
Oh, there we go.
Melts to a nice
It kind of has a weird color.
silver colour, and Neil managed
Oh, that's the metal, and then this is, I don't know what that is.
to pour it out quite nicely, and you could see the silver metal. But unlike melting lead or indium, it seems to oxidize quite easily, reacts with the air. Thallium, because it is in group 13, has 3 electrons in its outer shell, and it can either lose 1 electron or 3 electrons when it makes a salt. So you can have thallium 1 or thallium 3. We had a nice bottle of thallium 3 nitrate, and Neil decided to make a solution in water, colourless salt, but when he added the water, much to his surprise, it went brown. Not what he expected.
Didn't expect that.
He thought the water might be contaminated. Clean water, same result. Phoned the professor at home. What did he think? I made some suggestions, add some acid. No difference, it always went brown. We think it's some sort of decomposition, but Neil quickly lost patience. So instead, he decided to heat the solid thallium nitrate in test tube. Heavy metal nitrates tend to decompose to nitrogen dioxide, a brown gas, and the oxide, and the thallium nitrate didn't disappoint. Big clouds of nitrogen dioxide. Much better results with the thallium 1 salt. Was a bit nervous, might go brown again, but it was much better, a nice colourless solution. So he tried reacting that solution with, first of all, a solution of iodide, I-, and there was beautiful precipitate.
Gorgeous.
Of yellow thallium iodide. It's still one of the most beautiful sights for a chemist, seeing precipitation of a solid. Even Brady got quite excited, made Neil do it a second time just to see it. So finally, Neil tried sodium sulfide, and many metal sulfides are coloured. Sodium sulfide makes a colourless solution, added the thallium solution, which was also colourless, and a terrific, almost black precipitate. The black precipitate is thallium sulfide. It may well be a mixture of thallium 3 and thallium 1, but it's a sulfide. Most metal.
It's pretty crazy how a clear liquid and another clear liquid can mix together and make a black solid. It's weird.
Sulfides are black. A few have bright colours. I was hoping for something exciting, but it still looked really nice.
Black's exciting, that's cool.
The interesting question is, why is thallium called thallium? And it turns out that being in the garden is quite an appropriate place to discuss the name thallium. It was discovered by two people almost simultaneously in 1861, before Mendeleev had proposed the periodic table. So nobody was sure where there were missing elements. And there were two rival scientists, Lamy in France and William Crookes in the UK. And Crookes had been studying spectra, the light emitted by high temperature samples of salts. And he saw a green line in the spectrum that he thought nobody had ever seen before. And he declared that he had discovered a new element. He was so excited by the colour that he chose a Greek name after the Greek word thallós, which apparently means the green colour of a shoot of a tree just as it bursts into leaf. It's quite strange that anybody should have a word for this, but so this is thallós, after which thallium is named. Unfortunately, Crookes only had some residues which came from processing selenium minerals. Probably, I don't know, some quite horrible gunge from an industrial reactor from Germany. So he didn't really have much material in which to try and isolate this element. But he got a small sample. There was a big exhibition in London when people apparently were exhibiting chemical things in the hope of getting a medal. Crookes displayed his spectral evidence plus some what he thought was a small sample of thallium, and Lamy arrived from France with a large lump of thallium metal. So Lamy got the medal, and Crookes was furious because he wanted his discovery to make him a Fellow of the Royal Society. If you don't know about the Royal Society, watch Brady's channel Objectivity.
Do it, there it is, there.
Crookes was weighing some chemicals, so he invented radiometers to explore that, but they became a bit of a scientific toy.
Crookes made a fuss, and he got a medal as well, and I think eventually became a Fellow of the Royal Society. Now, the important point of this is that scientists were just as competitive, just as selfish then as they are now, sadly. And you shouldn't think that scientists long ago were wonderfully saint-like figures. They were just like us. Now, the thing that I think is really quite interesting is that Lamy and Crookes were invited to meet each other in London, but he couldn't speak French and Lamy couldn't speak English, so they couldn't really communicate. So that also demonstrates the value of being able to speak foreign languages and the importance of communication in science.
Why did Crookes get to name the element?
Well, he published first, and there is a paper which actually says, I should not have ventured to offer to the society, that's the Royal Society, so incomplete a notice as the present one. That's his description of his work. Had I not within the last week heard that a continental chemist, Professor Lamy of Lille, has recently been fortunate enough to, etc. So he was desperate to publish first. According to Crookes' original manuscript, he even tasted the thallium. Of course, having heard about this green colour, Neil and Brady were keen to see it for themselves. And with a bit of playing around...
It doesn't seem good that he tasted it, because they said it was poisonous. What if he lost all his hair? He probably did. Maybe. I don't know.
They got a really nice green colour in the flame. And the most amazing thing is that I think most chemists nowadays, have no idea that thallium was named because it was green, or that it even gives a green flame test. Part of my research involves looking at the absorption of infrared light by solutions. If you want the light to get into the solution, you need a window that the infrared light will go through. Materials like glass absorb infrared light very strongly, but the best materials are crystals where the ions are large, because infrared light is absorbed by the vibration of ions and atoms, and if you have big, heavy ions, they vibrate more slowly and therefore only absorb infrared light at very long wavelengths. So I have in my office a nice sample of material which has a trade name, KRS5.
Those are neat little, what are they called? Models. They're cool looking.
Which is a mixture of thallium iodide and bromide, which can be polished to a really nice transparent material. It's a sort of pinky orange colour, and Neil was quite excited. He looked at Brady through it. But it was always quite frightening to work with, because when you polished it, of course, dust of thallium salts came off, and you had to be very careful not to be poisoned. So finally, to come back to the murders, there is an Agatha Christie thriller, a book, murder mystery, I won't tell you which one, where the clue is that the victim's hair falls out.
The pattern of decomposition suggests that there was poison present.
And they've been poisoned by thallium.
Yes.
All right, here we go.
You should begin to see that.
Well, that was a great video. Do not poison people with thallium. Thank you so much for watching, and we'll see you next time. Stay smart. Bye.